Fuller himself often spoke of the need to consider the Earth as a unified system, an idea that has grown more popular as environmental awareness increases. He believed in synergy, the principle that the total can be greater than the sum of its parts, and he poured his energy into exploring how synergy might lead to solutions never before imagined. His was a broad optimism. As long as we kept our minds open, shared knowledge widely, and questioned default assumptions, we might find new patterns that would change everything for the better.
Hello, today we are going to talk about the Geodesic Dome by Bucky Fuller with respect to the ideas of synergy. Synergy means the behavior of all systems unpredicted by the behavior of their parts taken separately.
Things in a fresh way. By far, however, his most iconic contribution is the Geodesic Dome, popularly linked to Fuller, though the earliest concept was pioneered by others decades before. This dome design arranges triangles in such a way that stresses are distributed evenly throughout the structure. In practice, it's a marvel. It can be unbelievably lightweight while covering vast areas with minimal materials. For any set diameter, the geodesic dome encloses the greatest amount of space with the least surface area. This efficiency was nearly irresistible to industries in need of large covered areas. This includes radar stations, exhibition halls, and storage facilities, and even futuristic houses. Fuller's name became so synonymous with geodesic domes that people around the globe started calling him the Dome Man. Everyone from the military to environmental activists tried adapting the structure because it could be assembled quickly and endure substantial wind or snow loads without collapsing. Geodesic dome houses, sometimes called dome homes, pop up in unexpected places. In some climates, they function wonderfully by distributing rain and wind pressure. In others, owners have discovered the geometry can make them tricky to wire, insulate, or partition with standard building materials. Nonetheless, the practical benefits, combined with their dramatic visual impact, have attracted many people willing to put in some extra work to adapt them for modern living. These homes look futuristic even decades after the concept was popularized, a testament to Fuller's ahead-of-its-time thinking. He was convinced the dome was the perfect marriage of geometry and functionality, letting owners maximize internal space and minimize material use. Fuller's endless curiosity about structure didn't stop at domes. He also toyed with tensegrity, a term he coined by blending tension and integrity. Tensegrity structures combine rigid struts under compression with flexible cables under tension to create stable, self-supporting frameworks. They can look like floating sculptures of rods and cables, able to stand with an almost magical lightness. This same principle shows up in nature. Our own bodies exhibit tensegrity in the way bones and muscles interact, so Fuller recognized that the principle could translate into architecture and product design. Although tensegrity has remained somewhat specialized, it has had noticeable ripples in engineering, robotics, and contemporary art. Every time you see those carefully balanced wire and rod sculptures, you're seeing the legacy of Fuller's passion for structural innovation. Buckminster Fuller's grand sense of possibility.
The Geodesic Dome is Fuller's most famous design principle that employs the idea of synergy. Fuller's synergy is about leveraging design principles to achieve optimal performance. The Geodesic Dome is a lightweight and exceptionally strong structure, designed to cover large areas without internal supports. This big breakthrough design was widely adopted for military, industrial, and ecological uses due to its strength, cost-effectiveness, and sustainability. Thousands of geodesic domes have been built around the world. A geodesic dome is a hemispherical thin-shell structure, lattice-shell, based on a geodesic polyhedron. The rigid triangular elements of the dome distribute stress throughout the structure, making geodesic domes